Hello everyone, myself Professor Kishan GS, Assistant Professor, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. Today I will be dealing with the subject fluid power system for 7th semester mechanical engineering student. So the subject code being 17ME72, and now we are discussing the topic related to module 4, and the topic for today's discussion is air compressor and its types. So far we have studied different components of fluid power system. So one of the major component of fluid power system when it comes to hydraulics is the pump. So we say pump as the heart of fluid power system, or basically hydraulic system. Similarly, when it comes to pneumatic systems, it is the air compressor which is to be considered as the heart of pneumatic system. So whatever the pattern in which we have studied the concept of pumps in case of hydraulics, okay, same thing is going to be considered here when we talk with the topic considered as the air compressor. So how do you define air compressor? Air compressor is a machine that compresses the air from a low inlet pressure. So low inlet pressure is usually preferred as the atmospheric pressure, which in case we are going to consider to define the air compressor. So low inlet pressure to a higher desired pressure level. So as in case of pump, here also it is the increase in the pressure of the air which is to be taken into account for pneumatic application or execution of pneumatic application. So basically when we speak about the air compressor, the functionality remains as same as the hydraulic pumps, but the only change is that the working fluid is air here, whereas in case of fluid pump it is the water or oil or any kind of fluid source. Okay. Next comes the topic called as types of air compressor. So we have basically three types of air compressors now. So first one being reciprocating piston type, second being rotary screw type, and the third one being rotary vane type. So here the constructional details is as similar to that of the hydraulic pumps, only the change is that the working fluid is different. Okay, so three types. Here, reciprocating piston type, so the functionality looks as similar to that of an IC engine here. So here what happens, so we are going to study the constructional details, its working. So similarly for other two types of air compressors as well. Basically there is a keynote when we speak on air compressor. So what is that keynote? The keynote speaks like this: air compressors are positive displacement units, means to say that here successive volume of air are confined within the closed space and are elevated to higher pressure, means to say that without any losses you are going to consider the the volume of air or any related gas which is to be compressed in case of air compressor here. So that is going to be considered. So the successive volume of air are confined within the closed space, means to say that the air is enclosed in the closed space without any losses. Okay, so that is what the meaning of confined comes into picture, and thereby without any losses, considering the air inside the space, that air which is inside the space will be elevated into higher pressure, means its pressure will be increased. So here we go with the direct concept of the reduction in the volume that leads to the extension or elevated into its higher pressure level. Okay, this is about the brief introduction regarding air compressor. So it is a device that compresses the air from lower inlet pressure to higher elevated desired pressure level. So we have three types of compressor: reciprocating piston type, rotary screw type, rotary vane type. So the constructional details and working principle remains as similar to that of hydraulic pump here, but the only change is that the working fluid is compressed air in case of air compressor. Okay, so what happens in case of the major thing here? Here in case of air compressor, there will be no losses in the fluid or the air particles which are considered inside the closed space. So this is a very important aspect or introduction to air compressor. Now let us take up the three different types of air compressors which are taken into the study. So first one being reciprocated or reciprocating piston type of air compressor. So here the constructional details looks with an chamber wherein the air is being considered and compressed and kept it in the container. So that particular container is usually called as reservoir. Okay, so basically when we have any air compressors here, so it is the general tendency that there will be a cylinder like structure present at the lower bottom surface. Okay, that is nothing but the reservoir which compresses or which houses the compressed air into it. Okay, so basic applications, if we have observed, in case of bicycle or two-wheeler puncture shop, there will be a presence of air compressor. So there will be extended part of air compressing unit at the top, whereas a cylindrical structure will be present at the bottom, which is nothing but a reservoir to hold the compressed air. Okay, so here we are speaking about that extended part that leads to the process of compression. We are not going to show any kind of cylindrical structure that houses the compressed air for your kind information. Okay, so moving on with the reciprocating type of piston type of air compressor. So it will be a cylinder with piston arrangement wherein the connecting rod from the piston will be extended to its support onto the crankshaft. Means to say that the crankshaft drives the connecting rod, and connecting rod which is in contact with the piston reciprocates within the cylinder, that leads to the process of compression of air, and it is increasing the pressure from lower level to higher level. So here is the the constructional detail of reciprocating piston type here. So we have a connecting rod, and the extended part of connecting rod is projected towards the extension for crankshaft, and we have a piston in connection with the connecting rod. So the diameter of piston is very close in tolerance with respect to the outer diameter of the cylinder here, and we have two openings, inlet and outlet, as it is needed for the suction of air and as it is needed for the sending out of compressed air out of the the reciprocated type of air compressor. Okay, so here what happens, so as the air which is naturally available will be taken into the inlet due to the driving force given by the crankshaft onto the connecting rod. Once you switch on the supply, so maybe electrical supply, what happens, the crankshaft tend to rotate along a particular direction. This rotational energy of crankshaft is transferred onto the connecting rod such that the connecting rod transfers the energy received from the crankshaft onto the piston and lead to the movement of piston in the reciprocatory fashion. Means to say that along the horizontal direction according to the construction. So when there is a movement of piston from left hand side to the right hand side, there will be suction of the air which is needed to be compressed. So the air which enters into the inlet gets accumulated in the chamber here. Then what happens, the piston reciprocate back from right side to the left side. So thereby what happens, whatever the air particles which are present here inside the chamber, that will be compressed and the pressure of that particular air will be increased. So the compressive force onto the air depends upon the power which is being driven, which is the driven force from the crankshaft towards the piston. So thereby what happens, the air particles which has entered through the inlet will be compressed, and that compressed air will be sent out of the outlet from the compressor, so that the compressed air is considered for any kind of pneumatic application. So basically in case of pneumatic system, the compressed air coming out of the air compressor will be the actual driving agent to perform operations in pneumatic field. Okay, so this is about reciprocating piston type. It is as similar to reciprocating piston type of hydraulic linear actuator, okay, or linear pump. So here comes the rotary screw type of air compressor. So the construction and working remains as similar to that of the screw pump what we have studied in case of hydraulics. So here also we will be having a chamber. Okay, so we will be having the rotating screws. The screws are arranged such that whatever the air which is entering into the air compressor, the air particles are moved to slide over the gap present between the threads in both the screws here, and thereby that increases the pressure of air which is entering into the compressor. So if you just observe the construction here, we have rotating screws here. Okay, there will be an external power source that drives both the rotating screws. So since the rotating screws are in contact with each other, both the rotating screws will work or rotate in the opposite direction. So when they are in contact and rotating in the opposite direction, the point of contact wherein both the rotating screws comes into picture leads to the suction of air particles from the surrounding. So that is the inlet which is for this type of compressor. So through the inlet there will be the natural air which is available outside will be taken into the compressor, and that air particle is made to pass through the grooves or the gap between the rotating threads. So since it is allowed to pass through the alternative threads simultaneously on both the screws, there will be increase in the pressure with the reduction in the volume here. Thereby what happens? The air which has entered into this rotatory screw type of air compressor will be compressed once it is being made to pass through the rotating screws, and thereby what happens? The pressure of the air which is passing out of the rotating screws will be at very high pressure than the inlet pressure, and that will be stored in the chamber here and will be having the outlet wherein the compressed air will be sent out of the rotatory screw type of air compressor. It is only to a percentage of the conversion of the pressure from lower level to higher level. Next comes the third type of air compressor, that is rotating vane type or rotary vane type of air compressor. This works basically as in case of the vane pump. Okay, so similarly we will be having a rotating member housed by the casing or stationary wheel, and the rotating wheel will be having vanes, okay, or the radial slots on its periphery. The rotating wheel or the rotor and the stationary wheel will be kept at a distance with the center to center distance called as eccentricity, as in case of pump here also. Okay, so we'll be having inlet and outlet, and we'll be having the radial slots created on the rotating vane, rotating rotor, and it is housed using a stationary wheel here. So you can observe the direction of rotation of the rotating member. So thereby what happens? Whatever the air which is entering into the rotatory vane type of air compressor, that will be made to enter into the stationary wheel or into the space between the stationary wheel and the rotor, and thereby what happens? These vanes which are positioned inside the entire compressor carries the air which is entered into here, and thereby what happens? There is increase in the area for the air to enter into it, whereas as it is subjected to the rotation of rotating member or the rotor, thereby what happens? Between the gap between the vanes, okay, as it is subjected to rotation, there will be compression or reduction in the space for the air particles to pass from inlet to outlet. So this reduction in the area leads to the compression force being applied on the air particle, and thereby what happens? The air which is entered into the rotary vane type of air compressor will be compressed, and the compressed air will be sent out of the outlet for any kind of applications, or that will be taken for driving any kind of pneumatic application. So this is something regarding rotary vane type of air compressor. Remember two things: air compressor considers the presence of air and compresses it from lower inlet pressure to higher inlet pressure, whereas in case of hydraulic pump, it considers water or oil or any fluid source from lower pressure level to higher pressure level. Why we need this higher pressure level of the the working medium for a fluid power system or fluid power application? Whenever we are targeting the assistance or whenever we are in need of fluid power applications, at that particular point of time, the pressurized working medium is what is taken to be account, that leads to extensive dragging or extensive capacity for carrying the load, and this is where the high pressurized working medium is required for the fluid power system for both hydraulics as well as pneumatics. So this is about today's session on air compressor. Welcome to the session on fluid conditioners in the subject fluid power system 17M72 for module 4. So in this today's session, we are going to study the complete aspects of fluid conditioners. Okay, so basically the major purpose of having a fluid conditioning unit in pneumatic system is to ensure that the air which is being considered as a working fluid is the preferred medium for the practical applications wherein the pneumatic system is being targeted. So the major purpose of fluid conditioner is to make air as the preferred medium in the pneumatic application. See, generally we take the air which is available abundantly in the atmosphere, we are going to compress the air and we are going to take that particular pressurized air to perform certain actions that lead to the particular application. So here, in order to ensure that the application defined or the targeted is achieved, the air should be at a very preferred rate, which should not contain any type of contaminants. It should be with the regulated pressure or the optimum pressure as it is required as such. Okay, so keeping all those things in mind, conditioning of fluid is nothing but ensuring the air which has entered into the pneumatic system is the preferred medium, or it is given with certain qualities that leads to the proper implementation of pneumatic application. So in order to assist the conditioning of fluid or treatment of the fluid, we have different types of fluid conditioners or different types of fluid conditioning units. So first one being filters. Okay, so as the name itself says filter, it is the device or the component in the pneumatic system that is considered to trap the contaminants or the dirt particles which are accountable in the flow of air in the pneumatic system. So basically filters are considered at different locations in the pneumatic system where and all there will be a chance of adaptation of dust particles along with the flow of air. Okay. Next comes the regulator. As the name itself suggests, regulator, it is to regulate or moderate. Here, specifically to speak on the regulator, it is the pressure regulators. Okay. So since we are targeting the compressed air here in the pneumatic system, so the pressure or the compressed air should possess a particular pressure only that leads to the satisfaction of performance of work or the application. So hence the regulators are those devices that try to retain the constant pressure in the air which is being considered as the working medium. Next comes the lubricator. See, since we are targeting pneumatic system here, okay, so we don't have any option of the lubrication that is necessary along with the fluid medium, but there are moving parts that are accountable for the performance or the satisfactory conditions that lead to targeted application. Hence, to that particular moving parts, in order to satisfy the lubrication that leads to the better performance of the moving parts as well as that reduces the wear and tear of the moving parts, you need to have lubrication. Hence, the lubricators will also play a vital role being a part of fluid conditioners. Keep in mind, if the lubrication leads to excess amount of addition of oil into the compressed air, then the system collapses. Hence, there will be a huge amount of care taken on the lubricatory part that leads in the pneumatic system. So we are going to study it in detail once we take up the lubrication unit. Next comes the air dryer. See, though the air is being compressed to a higher pressure than the inlet pressure, the air particle consists of huge amount of moisture in it. This moisture may lead to certain adverse effects like mismatching in the movement of moving parts, or that may even lead to the corrosion of the particles or the components present in the pneumatic system, as well as it also affects the inherent properties of the compressed air if the moisture content is more. Hence, the air dryers are taken that leads to the trapping up of moisture content which is present in the compressed air or the fluid medium which is taken in pneumatic system. Last comes the mufflers. The mufflers are the devices just like silencers. Here, the mufflers in pneumatic system are considered as pneumatic silencers. Okay, so the pneumatic silencers are the devices that results in safe and quiet exit of the pressurized air into the atmosphere. Once the entire performance or the practical application is being considered, okay, the pressurized gases or the air which is to be taken out of the pneumatic system will be fed against the mufflers so that the mufflers lead to the safe and quiet exit of that particular pressurized gas into the atmosphere once it has completed the satisfactory working principle. So this is about the different types in brief regarding to the fluid conditioning unit. Now let us take the important topic FRL unit, that is filter, regulator and lubricating unit. So here now we are going to study in detail regarding the FRL unit. What is meant by F? F stands for filters. As we know, filters are the devices that are targeted for the trapping up of contaminants or the dirt particles present in the air, which is the flow medium in the pneumatic system. But here there are two different types of filters that are considered to trap the contaminants or the dirt particles. First one being the dry filters. So dry filters are similar to that of the filters which are available in motor cars. Okay, we do have the trapping unit wherein the air will be made to pass through the replaceable cartridge, wherein the cartridge gets the capacity of trapping the contaminants or the dirt particles onto its surface. Whereas in case of wet filters are also called as wire mesh filters. The name wet filter is taken based on the working principle which is considered for the operation of the filter here. So here if you observe in this particular platform, the air particle which has entered into the pneumatic system will be made to pass through the oil bath, wherein the oil bath results in bubbling activity for the air particles that is being made to pass through the oil bath, and then that particular air which has been passed through the oil bath, which has resulted in the bubble formation, is made to enter into the wire mesh. Once it passes through the wire mesh, the bubbling effect of the oil bath results in the loosening of the dirt particles in the mixture with respect to the air, and that particular dirt particles will be trapped by the wire mesh. Okay, hence this is considered as wet filters. Okay, wet filters. So this is something regarding dry filter and wet filter. The next type of fluid conditioning unit is regulators, or simply to say it is pressure regulators. So here the major purpose of pressure regulators is to retain the constant pressure of the pressurized gas or the compressed gas in the pneumatic system. Means to say that it has to result in the maintenance of the constant pressure in the air which is flowing in the entire pneumatic system. Okay, here we have three types of the pressure regulating or the three modes of pressure regulating units to be focused. First one being non-relieving regulator, next being relieving regulator, and the third one being electronically or electrically controlled type of pressure regulation. So we'll focus one by one now. The first one being non-relieving regulators. So observe the representation here. The air which is taken from the receiver is fed onto the pressure regulator here, and that particular pressurized air which is being taken from the receiver is sent directly into the load, and once there is a particular application being performed due to the application of load type A here, and then the air will be sent out of the system. Means to say that whatever the pressure in which air comes into the system from the receiver into the pressure regulator, the same amount of pressurized air will be fed onto the load A to perform the defined work. Here there will be no losses in the pressure or no addition in the pressure to the air which is coming from the receiver. Hence you don't have any other action apart from retaining the pressure of air, and that particular retained pressurized air will be sent into the system to perform the work through the load A, and thereby at the exit there will be the exit of the pressurized gas into the atmosphere from the system. Since you don't have any addition or any deletion of pressure variation in this particular pressure regulator, this system is called as non-relieving regulators, or means to say that non-relieving pressure regulators. Whereas if you take second one, the air which is being taken from the receiver is made to pass through the pressure regulator, if the air which is entering into the pressure regulator has excess amount of pressure than the required pressure to satisfy the load B, which is nothing but to perform particular work. Okay, if it is more than the requirement, then there will be a vent provided in the pressure regulator here itself, so that there will be opening given to the air, so that the excess amount of pressurized air will go out of the system in the pressure regulating unit here itself, and the required or the necessary amount of pressurized air will be sent into the load type B to perform particular action. Since you have the capacity here of maintaining or regulating the pressure, if it exceeds, you can remove the pressure directly from there itself, and you are going to feed the optimum pressurized air into the load B, or load B here is to perform particular work, and that results in relieving regulators, and this type of pressure regulation is called as relieving regulators. And the third one becomes the bit automated type of pressure regulating unit. Here you can observe there is a control valve, there is an electrical controller, there is a pressure transducer, and this is a type of work C being defined, and thereby there is the vent which is to lead the pressurized gas to go out of the system. Okay, that is to the atmosphere. So here what happens, the air which is being taken from the receiver is made to pass through the control valve, wherein the control valve tries to control the flow rate as well as the pressure at which the air it is to be taken into the system. So basically it is the directional control valve, flow control valve and the pressure control valve based on the type of application. So here the control valve results in the flow of fluid from the air receiver to the electrical controller here. Okay, so this is a closed loop system. Once it is been made to flow through the electrical controller, the pressure transducer identifies the pressure at which air is being entering into the system, and thereby it is being fed into the load type C to perform actual work. At that particular time, what it does is, if the pressure transducer observes or identifies the pressure at which the air is being considered or air is being taken into the system, and if that particular pressure matches with the necessary amount of pressure required to perform the work through the load C, then it feeds the air from the receiver to the load C to perform work, and at the end there will be the release of pressurized gas into the atmosphere. What happens if it is more? Okay, if the pressure transducer identifies the pressure at which the air is coming from the receiver is greater than the pressure required to perform the work, then it sends signal to the controller, wherein the controller makes the control valve activated and results in the exit of the pressurized gas from the system, so that the necessary amount of pressurized gas will be taken into the load C to perform particular work. It is as similar to the relieving regulator, but it is completely controlled by the electrical controlled system. So these are the three types of the pressure regulation units which is in focus with the fluid conditioning unit. Okay, next comes the major part, lubricator. As I have already said, excess amount of oil entry into the pneumatic system leads to the damage for the entire operating cycle of the pneumatic application. Hence, lubrication becomes a vital role for moving parts, and meanwhile the lubricating unit should also be taken care so that it doesn't get added with maximum amount of air particle that leads to the misfunctioning or malfunctioning of the pneumatic system. Keeping that in mind, a lubricator is a device here in pneumatic system which is considered to give lubrication for the moving part or ensure lubrication for the moving parts. Okay, so here what happens, this is the representation of a lubricator, and this is the graphical symbol that represents lubricator in pneumatic system. So observe the figure here, there is inlet, there is outlet. Okay, so below is the space inside the glass bowl that acts as a reservoir or the oil reservoir. Okay, so here what happens, the major point of focus is to be targeted on the head portion of the glass bowl. If you observe, there is a space for the oil droplets, there is a presence of needle valve, okay, and thereby the connectivity between the upper portion and the lower portion is held through a capillary tube which is being fitted with a check valve here. Okay, so the basic functionality of all these components plays a vital role in understanding the concept of lubricator. So the functioning of lubricator is just like the mixing up of petrol and air mixture as in case of carburetor. Here also the same principle works out, but we are going to understand it in bit different platform in comparison with the pneumatic application. So the air particle which has entered into the system will be made to get mixed with a mist of oil. A mist of oil will be mixed with the air, and the air enters into the glass bowl with the presence of oil mist in it. Okay, thereby what happens at the bottom, there will be a swirling action given in the baffle plate inside the glass bowl, such that that swirling action of air particles results in the collection of heavier density of oil particles to be collected at the bottom, which is been meant for the oil to get collected as it is the reservoir part in the glass bowl, whereas the lower denser particles of air with a fine mist amount of oil in it will be sent out of the outlet. So that air particles which consist of minimum most amount of oil in it acts as a lubricating unit in the moving parts. But how do we get this oil mist here? The oil which is present inside the oil reservoir, as well as the area wherein the upper portion is being provided, there will always be the concept of differences in the pressure and density that comes into picture. Due to the variation in the pressure, the oil here at the reservoir will be made to pass through the capillary tube into the top head portion, wherein it gets collected in the form of droplets. Okay, so this is due to the variation in the pressure difference. The presence of check valve always results in the flow of fluid from only one direction, means to say that here in this constructional detail, the check valve leads to the flow of fluid from this particular oil reservoir to the head, wherein it gets accumulated in the form of oil droplet. Once it gets accumulated, we do have the presence of needle valve, and needle valve is basically a flow control valve which controls the flow of oil into a system. Here what happens, the same needle valve will be considered here, and this needle valve provides opening so that the flow of oil droplets gets entered into the lubricating part or the lubricator in the form of mist of oil, and once it gets mixed with the air which is entering through the inlet, the air and oil mix together, and that particular mixture of air and oil will be sent into the lubricator, and that will be subjected to swirling action, and that swirling action results in the accumulation of denser particles of oil to get accumulated at the bottom, and lighter weight particles or the air along with a fine presence of oil along with the air will be taken out of the outlet, and that will be fed into the actuating medium. And this is what about the lubricator: filters, pressure regulators or regulators, followed by lubricators. If these things are arranged in line according to the application wherever it is needed, and that forms the structure called as FRL unit, that is filter, regulators and lubricating unit. As we have studied the functionality of filter, pressure regulator and lubricator, this forms FRL unit, that is the sequential arrangement of filter, pressure regulator and lubricator before the compressed air is being fed into the actuator. Here we have taken cylinder as the actuator here. Okay, so basically the combination of filter, pressure regulator and lubricator comes into picture when we target the secondary air treatment as a part of fluid conditioning. Primarily, the air which is entering into the compressor will be fed through the filter, and there will be the trapping up of contaminants in the filter itself. So that is the first or the primary stage of air treatment considered in the pneumatic system, followed by the secondary air treatment wherein the compressed air from the compressor or from the receiver will be made to pass through the filter, and thereby the filter traps the contaminants or the dirt particles if present any, and that will be sent onto the pressure regulator, and here the pressure regulator regulates the pressure of the compressed air to be constant, and that constant pressurized air will be fed onto the lubricator, wherein the lubricator will add the fine particles of lubrication onto the compressed air, and that lubricated pressurized compressed air with no dirt particles will be made to enter into the cylinder. So the lubricating medium which is being added with the compressed air results in the lubrication of reciprocatory parts in the linear actuator or cylinder in this particular case. So this is how the FRL unit, that is filter, pressure regulator and lubricating unit, perform its fluid conditioning in case of pneumatic system. Next comes one of the important part of fluid conditioning component, that is air dryer. The air dryer is preferred for the purpose of trapping the moisture content which is present in the air, which is derived from the atmosphere, to act as a working medium in the pneumatic application. If the air consists of maximum amount of moisture content, then it leads to malfunctioning of actuating mode in the pneumatic system. Hence, trapping up of moisture becomes one of the major issue in conditioning the air as a fluid in the pneumatic system. Here, one of the major type of air dryer is air filter and water trap separator. So the construction of air filter and water trap separator goes like this. It consists of a glass bowl which has two openings, one for inlet, another one for outlet. The bottom of the glass bowl is fixed with a drain plug that acts as a source to remove the condensed moisture or the water droplets which are accumulated at the bottom. Inside to the glass bowl there will be filter in line with the deflector cones on both the sides, and will be having a baffle plate. See, the presence of deflector cone and the baffle plate results in the swirling action of air particles which enters into the air filter and water trap separator. The air from the inlet enters into the glass bowl, and this deflector cone and the baffle plate results in the swirling action which is subjected onto the air which has entered into the system. So the air, once it has entered into the glass bowl, will be made to pass through the filter, and simultaneously the deflector cones and the baffle plate subject the filtered air particles to undergo swirling action. Due to the swirling action, the moisture content which is present in the air tries to come out of the air and gets settled at the bottom of the glass bowl, and that forms the condensed moisture content in the glass bowl at the bottom of glass bowl, and thereby the air particles will be released from its moisture content, and that will be sent out of the outlet from this particular component. And this is the air filter and water trap separator, a type of air dryer, and this is the graphical symbol that represents the air dryer in case of fluid conditioning unit. Thank you.